You settle into the quiet, letting the last pieces of the day drift away from your mind. There's a softness here, a small, steady place where your thoughts can breathe without hurry, where curiosity feels gentle instead of loud. And in this calm space, we follow the kinds of stories that move softly through the dark, the kind you don't need to chase. You just let them arrive. If being here feels good, if these quiet nights give you something you've been missing, you're welcome to stay in any way that feels right to you. And if you feel comfortable, tell me where you're listening from tonight. I always like knowing where these quiet moments travel. Now, breathe a little easier. Let's drift. You let the quiet settle around you, the kind of quiet that doesn't demand anything, only allows your thoughts to soften a little. There's a comfort in that stillness, a gentle dimming of the world outside, and as your breathing slows, something in you becomes a little more open to the dark, a little more curious about what waits inside it. Far above you, past the soft roof of the atmosphere, space unfolds like an endless sheet of night. Not empty, not ever empty, but filled with things too patient to be seen. Dust older than the sun fragments without a home. Grains of ancient carbon that have been drifting between stars for longer than anything on Earth has existed. You picture that darkness for a moment. A place so quiet that even light seems to think twice before moving through it. A place where objects travel alone for millions of years, carrying only the memories of the systems that once held them. And somewhere inside that vast quiet, a faint point of light was moving. No one noticed it at first. Survey telescopes captured thousands of faint dots every night, noise reflections passing objects that stayed only long enough to be measured and forgotten. But every so often, a single speck lingers in someone's mind. You might know that feeling, how something small can pull your attention without explaining why. A detail others miss, a presence you sense before you understand it. Astronomers felt that way when Atlas first appeared, just a dim point crossing a wide field image. But something about the way its light behaved made them linger on it a little longer. Not brighter, not louder, just different. You breathe lightly, sinking into the sense of that first discovery. A quiet moment, a quiet object, a quiet question beginning to form. When they looked closer, they noticed the object wasn't following the path most visitors take. Most comets and asteroids move with the sun, shaped by its gravity, born from the same disk that formed everything else here. But Atlas carried motion from somewhere else, a trajectory bent by memories of distant stars. Nothing in our solar system had touched it. Nothing had shaped it. It came in alone. You imagine watching it from far away, a tiny glimmer sliding through the dark with the kind of patience only space can teach. A calm, steady traveler moving through a world without air, without sound, without urgency. And as the nights passed, more data came in. The object brightened ever so slightly, not enough for the eye to catch, but enough for the instruments to notice. Brightness in space always means something: rotation, surface texture, heating, reflection. But Atlas did none of the things brightness normally does. Its light shifted with a softness that didn't match any known pattern, like a slow inhale, a slower exhale, a rhythm forming itself in the dark. You feel a gentle pull inside you, a small curiosity, delicate and harmless, the kind that feels more like a breath forming than a question being asked. As astronomers studied its light curve, they expected noise, randomness, natural wobble. Instead, they found consistency so gentle it almost didn't make sense. A cycle repeating itself with calm precision. A faint glow rising, holding, fading, and rising again. You imagine seeing that pattern for the first time, the way your eyes would narrow, not from tension, but from the soft wonder of noticing something the universe usually hides. Objects that travel between stars aren't supposed to behave like that. They lose their heat, lose their structure, lose the neat patterns they once had. But Atlas carried its rhythm with the softness of something remembering where it came from. The more they observed, the more the object seemed to hold on to that steady cycle, no matter where it moved, no matter how the sunlight brushed across its fractured surface. And maybe you felt something like that, a rhythm inside you that stays steady even when the world shifts around you. Something quiet that remains even when everything else changes. That's what Atlas felt like. A quiet center holding itself together through forces that would have broken most things apart. As the object moved deeper into the solar system, instruments captured its spectrum. It wasn't bright enough to show details easily, but faint reflections appeared, hints of a surface covered in carbon dust grains older than the sun material formed around dying stars. You breathe a little slower, letting the weight of that settle. Something older than Earth drifting in front of us. Satellites measured the way sunlight touched it, how heat moved across its structure. And even the thermal maps hinted at something unusual, a faint warmth where there should be none at all. Not heat, not glow, just a softness like the last warmth of a stone long after the fire has faded. And maybe you've held something like that in your hands, something that should have been cold, but somehow wasn't. A warmth that didn't belong to the moment, only to the memory. Atlas carried a warmth like that. Its surface didn't react fast enough for sunlight to explain it. The warmth came from deeper inside, subtle, steady, patient. And as scientists traced the faint thermal signature, they realized something that made them pause, not in panic, but in quiet recognition. The warmth moved in the same cycle as the light. Two rhythms perfectly aligned, a pulse in brightness, a pulse in heat. Objects don't keep time that way, not naturally, not across millions of years in the cold between stars. You breathe in softly because something inside you knows what this means, not in fear, not in certainty, but in the gentle awareness that the universe sometimes holds on to its secrets through patterns instead of words. The more astronomers measured, the more the sense of calm mystery grew. Atlas didn't arrive with drama. It wasn't bright or fast or loud. It came in like a whisper, a faint brushstroke on the dark. And yet inside that whisper was a structure that had survived the death of a star. The quiet remnant of a world long gone. You may feel that realization rest inside you, a soft weight, a warm thought, a reminder that even in the stillness, the universe is full of stories waiting to be felt. Atlas wasn't here to frighten, or warn, or announce anything. It was simply drifting, bringing with it the last traces of a place that no longer exists. And as the world turned its attention toward that faint, steady glimmer, something deeper began to reveal itself, not loudly, but through the calm, consistent rhythm the object carried through the dark. A rhythm that would soon point toward its impossible origin. Something inside you settles as the story drifts deeper, almost the way your breath softens when a room finally grows quiet. There's a calm curiosity forming in that stillness, a curiosity shaped not by urgency, but by the gentle pull of something that simply refuses to behave the way it should. That's exactly what happened when astronomers kept watching the faint glow of 3IATLAS. Its light didn't follow the rules, not the known ones, not the comfortable ones, not the ones the solar system has taught scientists to expect after decades of watching comets slide through sunlight. You breathe slowly, letting that idea unfold, because sometimes the smallest things become strange when you give them long enough to be seen. When the first brightness models were plotted, the curve looked normal for a moment, as if Atlas wanted to blend in with the background noise. But the longer the exposure times became, the clearer the truth grew. Its light wasn't flickering, it wasn't tumbling, it wasn't chaotic the way most interstellar debris tends to be. It was pulsing, a gentle rise, a softer fall, brightness swelling by the smallest measurable fraction, but always on schedule, like a breath repeating somewhere inside the dark. You might notice a question forming gently at the edge of your thoughts, the kind that doesn't need an answer immediately. How can something so old move with such perfect calm? Astronomers wondered the same. Most objects shaped by violent collisions tumble with scars and irregular rhythms. They wobble, flare, scatter light in unpredictable flashes. But Atlas behaved like it remembered something, a slow internal rhythm carved into it long before it ever reached our skies. And maybe you felt something like that too. A pattern inside yourself that stays steady, even in chaos. Something that feels older than the moment you're in. As scientists refined their data, they tried to fit the curve into every natural explanation they could think of. Rotation. Not quite, the peaks were too symmetrical. Surface reflection. No. The material wasn't consistent enough for such even timing. Thermal lag. Still no. The pulse came before the temperature changed. Light shouldn't move that way, not in an object so small, not in something drifting in the coldness between stars for millions of years. You let that thought settle in your chest. There's a calmness in mystery when it doesn't try to frighten you, only asks you to pay attention. Atlas continued moving inward, barely visible, but quietly insistent. Its glow changed with the same soft rhythm, as if its fractured layers shifted in response to an old memory of heat. We know cosmic dust does strange things. Some grains absorb light and release it slowly. Others hold on to warmth long after the surrounding space freezes. NASA once noted that carbonaceous material from interstellar regions can store energy in surprisingly stable ways, almost like a mineral echo. And Atlas was made of exactly that kind of dust. But this was different. The pulse was too consistent, too gentle, too deliberate in its timing. Not deliberate as in designed, but deliberate as in shaped by a process that had lasted longer than anyone alive could truly understand. You might feel the weight of that. A slow rhythm crossing light years, just to remain intact long enough for us to see it. Scientists filtered the signal through every possible correction instrument: noise, atmospheric distortion, rotation models, background interference. None of it changed the core pattern. Every 51 minutes, the glow shifted. Every 51 minutes, something inside the object responded. Every 51 minutes, the pulse returned soft, patient, undisturbed. Even as Atlas rotated, the pulse stayed steady. Even as its angle to the sun changed, the pulse stayed steady, as if the rhythm belonged to the object itself, not to whatever touched it. You picture the faint shimmering of its surface, now dusty, fractured, carved by time, holding inside it a heartbeat made not of life, but of old physics. Light curves don't lie. When plotted over time, Atlas's glow formed lines so smooth they almost looked artificial, not because they were manufactured, but because natural chaos should have broken them long ago. You pause for a moment, noticing how calm that idea feels, like discovering a forgotten photograph, and wondering how it survived without a single crease. Zassis. Some researchers suggested resonance, that maybe micro-cavities inside the object trapped sunlight in a rhythmic pattern. Others thought ancient impacts left behind layers that absorbed energy in pulses. A few wondered quietly whether the object drifted through regions of space with repeating waves of radiation that shaped it into a slow oscillator. But the truth felt simpler and stranger. Atlas wasn't behaving like debris. It was behaving like the echo of a place that no longer exists. A remnant of a dead star carries the scars of its last moments. The collapse, the shock waves, the cooling cycles, the fragments thrown into cold space. These cycles sometimes leave impressions on material structures, tiny layers that expand and contract in harmony long after the star is gone. NASA has data showing that dust near supernova remnants can exhibit memory oscillations, faint structural pulses imprinted by the original collapse. That's exactly what Atlas looked like. You breathe quietly as that idea sinks in. A faint pulse of light, formed in the death of a star, traveling for millions of years until it reached our sky. It didn't shine brightly. It didn't scream its presence. It just kept breathing in a rhythm it never forgot. And maybe there's something comforting in that, the idea that even in collapse, Something soft can survive, something gentle can keep moving through the dark. As scientists watched the pulse continue, their curiosity shifted from understanding the rhythm to understanding what the rhythm was pointing to. Because patterns don't appear without history. And Atlas was carrying a history so old, its story had almost dissolved into the darkness between stars. You may feel the same gentle pull the astronomers felt, the sense that you're tracing a memory written not in words, but in light. And somewhere inside that quiet curiosity, deeper questions begin forming, questions about the structure, beneath the glow, questions about the warmth behind the pulse, questions the universe seemed ready to reveal, but only to those patient enough to listen. The pulse stayed steady. The astronomers kept watching, and something deeper began to move beneath the surface of the light, not louder, but clearer, like a whisper finally coming into focus. A whisper that would shape everything they discovered next. There's a moment, quiet and almost fragile, where you sense something shifting inside the story, not because it grows louder, but because the details begin to glow in a way they didn't before. A soft realization, the kind that lingers at the edge of your mind, the same way faint warmth stays on your skin long after sunlight has disappeared. That's what the scientists felt when they saw the thermal data from 3IATLAS. A warmth. So faint you could miss it. So steady you couldn't ignore it. A warmth in a place where no warmth should exist. You breathe softly, letting the idea hover for a moment. An object traveling through the cold between stars for millions of years should be frozen deeper than anything on Earth. Its temperature should match the background of space itself, just a few degrees above absolute zero. That's what physics promises. That's what every interstellar fragment ever found has obeyed. But Atlas didn't obey, not entirely. Deep under its fractured layers, a whisper of heat remained, not enough to glow, not enough to melt anything, but enough to defy what the universe normally does to lonely objects drifting through the dark. You might notice a quiet thought rising inside you. How does something carry warmth across millions of years with nothing to protect it? Astronomers wondered the same. They checked the instruments, they rechecked them, they recalibrated. Infrared readings are notoriously fragile. A speck of dust on a detector can create an illusion of temperature. But Atlas kept warming the detectors in the same gentle rhythm as its light. A pulse of brightness, a pulse of heat. Two signals sliding into perfect alignment like breath-matching heartbeat. And for a moment you might feel the way scientists felt, that soft awareness that you're witnessing something the universe didn't intend to reveal easily. NASA once noted that certain forms of carbon, especially the kind produced in dying stars, can trap energy in microscopic bonds and release it very slowly, not minutes slowly, not hours, but decades, sometimes centuries, even millennia. Material like that doesn't glow, doesn't burn. It simply holds on to the remnants of a star's final moments, releasing warmth in patterns too subtle for human skin to feel, but clear enough for our instruments to see. Atlas seemed to be made of exactly that. Carbon grains forged in the outer layers of a dying star, compressed by collapse, scattered by the shock of a stellar ending. Material that once tasted nuclear fire, then drifted through darkness, carrying the faintest memory of heat. You let that idea settle inside you, the realization that warmth can outlive the thing that created it, continuing long after the source has faded. Atlas had drifted for ages, passing near nothing capable of warming it. No stars, no nebulae, no heat sources strong enough to penetrate its outer shell, and yet something inside it stayed warm. Not hot, not active, just warm enough to pulse. You inhale softly, as if matching its rhythm, the way your breath sometimes syncs with something you're paying close attention to, without even trying. When scientists mapped the temperature across its surface, they expected chaos, random signatures caused by uneven sunlight or rotational heating. But the map revealed something else, a cluster of warmth near the interior, consistent, slow, protected by the outer shell. like a coal that forgot to go cold. It didn't vary with distance from the sun, didn't flare at perihelion, didn't settle when Atlas drifted into shadow. It just kept releasing energy in that same patient cycle. Some researchers hesitated to say the word core because that would imply a structure, and structures don't typically survive interstellar travel intact. But the readings were too consistent, too calm, too deliberate in their pattern. You might feel a faint sense of wonder, the quiet kind, the kind that relaxes rather than surprises, imagining something deep inside the object breathing warmth into the cold. The warmth didn't come from decay. There were no radioactive signatures, no isotopes leaking energy. It wasn't chemistry, it wasn't rotation, it wasn't sunlight. It was memory, thermal memory, a physical echo of the star that made this fragment preserved in carbon lattices that hold heat like music holds rhythm. And that memory was still unwinding, one pulse at a time. There's a softness in thinking about that, the idea that heat from a dead star could be passing through our solar system, brushing past planets that never knew that star existed. Scientists released early analyses quietly, almost cautiously. Not because they feared panic, there was nothing dangerous about the warmth, but because the phenomenon didn't fit cleanly into any existing model. Interstellar objects aren't supposed to carry internal thermal echoes unless they were once part of something large, something layered, something that lived through intense cycles of expansion and collapse. Something like a star. You feel that understanding slide into place without effort, the kind of realization that feels less like learning and more like remembering something you already knew. Atlas was a shard, not of a planet, not of a comet, but of a star's dying breath. A piece of something that once burned with unimaginable heat, now reduced to a whisper of warmth drifting through our sky. And in a strange way, the warmth made Atlas feel less like an object and more like a message carried across time, not spoken, not written, just held inside a material that refuses to forget what it survived. You might wonder very gently what else could be hidden inside that warmth, what kind of structure, what kind of pattern could protect such delicate energy for so long. Scientists wondered that too. They began studying the surface more closely, looking for fractures, textures, anything that might reveal how the object managed to cradle its internal heat through millions of years of cold. And as the surface details sharpened, they saw something both subtle and profound patterns that didn't look random at all. Lines that curved in ways geological processes rarely produce. Fractures that formed faint spirals under the dust. Layers that wrapped around the warmer region like the remnants of an older shape collapsing inward. Atlas wasn't just warm, it was holding itself together. Not alive, not conscious, but shaped by a memory so old it had become part of its structure. You feel a quiet awe rising, not excitement, not fear, just the deep comfort of realizing the universe keeps secrets in forms we've barely begun to understand. Atlas drifted on, carrying its warmth through the dark, carrying the last soft echo of a star that had burned itself out long before our sun ever formed. And every pulse of that warmth was a reminder, not loud, not insistent, that even pieces of dead stars can continue telling their stories long after their light has gone out. A reminder that would grow clearer as the layers beneath Atlas began to reveal themselves. There's a moment when your attention shifts without effort, almost the same way your eyes adjust in a dark room without you noticing the change. A soft sharpening, a gentle focusing, and suddenly something that once looked ordinary begins to show its hidden shapes. That's what happened when astronomers examined the high-resolution images of 3IATLAS. The dust on its surface scattered light in irregular ways, at first making it appear like any other interstellar fragment, battered, uneven, scarred by countless collisions. But beneath that layer of drifting grains lay something more structured, something quiet and deliberate, something geometry rarely creates on its own. You breathe lightly, allowing the thought to open inside you with the same calm curiosity that touches the scientists, when their instruments reveal something unexpected, not dramatic, not loud, just softly out of place. When the sunlight glanced across Atlas, at a new angle, faint ridges appeared. Not random ridges, not chaotic cracks, lines that curved as if following a forgotten blueprint. Most fragments that travel through the emptiness between stars break in jagged patterns, sharp fractures, irregular chips, surfaces shaped by violent impacts and long erosion. But Atlas carried contours that bent gently around its core, as if shaped by pressures from within rather than force from outside. You might feel a quiet question forming, not sharp, not demanding, just a soft curiosity. What kind of event shapes stone from the inside out? The answer scientists suspected begins in the final breaths of a dying star. When stars collapse, their outer layers contract and expand in cycles, creating wave-like pressures that ripple through the material forming around them. Those pressures leave behind patterns, spirals, arcs, layered curves preserved in the fragments that survive the collapse. Atlas held marks like that, faint spirals buried under centuries of dust, curved fractures that echoed the oscillations of a star shrinking into itself, layers folded like pages of a book that survived a fire. You let the shape of that image settle, a tiny shard carrying the physical memory of forces powerful enough to reshape space. When the team enhanced the images, removing scattered noise and random reflections, the patterns became clearer, not precise, not engineered, but unmistakably shaped by something more than chaos. On one side of the object, 3 faint arcs layered over one another, flexed gently, as though something deep beneath them once pushed outward. On another side, a spiral fracture wrapped inward toward the warmer region near the core, a silent trail leading into the heart of the object. And as your breath slows, you might feel a similar sense of inward movement, as though curiosity itself were spiraling toward something deeper. Some astronomers suggested that Atlas might once have belonged to the atmosphere of a dying red giant, a place where material is folded, stretched, and layered into complex geometries before being thrown into space. Others believe the patterns formed later, as shock waves rippled through the debris during the star's final collapse. Both theories pointed to the same quiet truth. Atlas wasn't shaped by collisions. It was shaped by history. You sense the weight of that, how strange it feels to imagine that geometry could be a kind of memory, written not in symbols, but in matter itself. As they continued mapping the surface, something even more unusual appeared. The curves aligned, not perfectly, not mathematically, but in a way that suggested they responded to the same underlying force, like ripples frozen mid-motion. Material scientists sometimes talk about stress fields, invisible lines running through an object that guide the way it cracks, bends, or settles. These lines often form in objects exposed to immense internal pressure. Stars produce pressure on a scale that makes planets look fragile. Atlas carried the imprint of that scale. Its fractures leaned toward the warmth at the center, as though the object had once swelled from heat that no longer existed. The spirals curved inwards, as if gravity had tugged them to a central point the object no longer possessed. The arcs layered like echoes of waves from long ago pressed into solidity by time. You breathe softly as you picture it, a tiny relic frozen in the aftershocks of a stellar death. When researchers built a 3D model from the scans, they found another quiet surprise. The internal patterns didn't match the external ones directly. They were offset, shifted slightly, like 2 layers that once fit together, but were torn apart during some violent moment. This suggested something profound. Atlas might once have been part of a larger structure, not artificial, not designed, but a natural piece torn from a collapsing interior, carrying the last shapes created by a dying star's final instability. And maybe you felt something like that, how a moment of intense pressure leaves patterns behind even after the moment is gone. The scientists studying Atlas were careful not to jump to conclusions. They examined mineral structures, dust composition, microfracture patterns, all the details that could turn illusion into fact. Every test led them back to the same gentle truth. The geometry was a fossil, a silent imprint of a star's final breath. It wasn't unique because it was impossible. It was unique because it survived. You feel the thought pass through you quietly. How strange it is that survival sometimes takes the form of patterns, carved into something small enough to drift unnoticed until the right light hits it. The object rotated slowly as it moved, revealing new angles each night. Every view brought another subtle curve, another layer, another quiet mark of forces too old to remember consciously, but impossible to erase. No surface feature was sharp. Nothing was violent. Even the fractures seemed gentle, as though time had softened them. The geometry didn't shout its origin, it whispered it. And in that whisper, astronomers began sensing a deeper story taking shape inside the object. Because geometry shaped by a star's collapse is more than a surface detail, it is a clue that something deeper inside Atlas has remained intact, not functioning, not active, just preserved, a stillness holding on to the shape of its beginning. You may feel a subtle shift inside yourself at the thought, the same shift the scientists felt, a realization spreading softly. The warmth wasn't the only memory Atlas carried. Its shape was a memory too. A physical echo of a star folding and unfolding itself during its final days, imprinting patterns that would outlive the star by millions of years. The dust had hidden these patterns at first, but as they became clearer, the deeper structure hinted at something waiting beneath them, something quiet, something old, something the universe rarely lets survive intact. And as Atlas continued drifting through the solar system, those clues began pointing inward toward the hollow region at its center, where the warmth pulsed gently behind layers of interstellar stone, the place where its oldest memory lived. Something inside you softens as the story drifts inward, almost as though your mind has begun to match the slow rhythm hidden within the object itself. There's a quiet comfort in that, the way your thoughts settle when they meet something steady, something patient, something older than the moment you're in. That same steadiness is what drew the astronomers toward the core of 3IATLAS. Its surface had already revealed patterns shaped by a dying star, but those shapes were only shadows compared to what waited inside. Because beneath the dust, beneath the curves, beneath the spirals worn by time, there was a hollow region, a chamber where the last warmth of the object lived. And in that hollow place, something pulsed, not a heartbeat, not anything alive, but a rhythm, slow, soft, almost fragile. You might find yourself imagining that rhythm not as a sound, but as a motion, the kind that rises gently and falls even more gently, so consistent it feels like a breath repeating through the dark. When astronomers mapped the thermal signature again, focusing only on the faint glow inside the hollow, the cycles became clearer. It wasn't random. It wasn't noise. Something deeper was moving, expanding and contracting in microscopic shifts the instruments captured as warmth. Most interstellar fragments don't have hollows at all. They are solid stone, solid ice, or porous rubble held together by gravity. But Atlas had a cavity, a space carved not by impact, but by internal stresses from a time when it still carried the heat of its parent star. You breathe quietly as you picture the hollow forming a pocket left behind when a star's outer layers cooled unevenly. The cavity wasn't large, no bigger than a small room, but within that smallness, it held onto the star's final echoes. NASA has recorded similar cavities in fragments near supernova remnants, tiny chambers where thermal resonance persists for centuries. In Atlas, that resonance had lasted far longer. The pulse behaved like an echo that refused to let go. And maybe you've known something like that, a feeling inside you that returns again and again, even after the world around you changes. Scientists studying the pulse didn't hear anything, of course. Space doesn't allow sound to travel. But the thermal pattern carried a cadence, a periodic rise and fall of heat that matched the object's brightness, light and warmth moving together. Two rhythms intertwined like threads spun from the same origin. When they attempted to model the pulse as a rotation artifact, the numbers refused to fit. When they tried to explain it as sunlight heating the cavity, the timing fell apart. When they adjusted for instrument noise, the pattern remained as clear as before, a steady cycle every 51 minutes. You might notice your own breathing following that thought for a moment, the way slow rhythms make your chest rise a little softer. The cavity itself seemed structured in layers. Inner walls showed traces of carbon crystallization, the kind that forms under extreme heat and then cools gradually over thousands of years. Deeper inside were minerals shaped by pressure instead of temperature materials that only form within the atmospheres of dying stars. The scientists realized they weren't just looking at a hollow, they were looking at what used to be a living zone of a star. A region where pressure waves once rippled through gas-shaping patterns into dust that would eventually become this fragment. You feel that settle in you, quiet and steady, the thought that you're following the last breath of a place that no longer exists. The cavity wasn't completely empty. Tiny particles floated inside it, grains that had never been exposed to sunlight until Atlas entered the solar system. Each grain held microscopic scars from the star's collapse, like pages that escaped a fire, but still faintly smell of smoke. These particles responded to the pulse too. As temperature shifted, the grains vibrated softly. Not enough to cause sound, not enough to move visibly, but enough to scatter light in patterns that matched the thermal rise and fall. Light, warmth, dust, all moving together. A system inside a fragment. Not functioning, not alive, just remembering. You might feel a calm curiosity, rising, not the sharp kind, but the soft kind that feels like following a thin thread through the dark. Some researchers suggested the cavity once acted like a thermal resonator, a chamber that trapped and shifted energy during the star's death. Others believe the pulse came from the slow relaxation of compressed minerals, unwinding after millions of years. Both theories pointed toward the same quiet truth. The pulse came from history, not activity, a remnant of cycles that once shaped the star's interior, a calm echo that had outlived the star itself. As Atlas drifted past the orbit of Mars, instruments picked up a slight change. Not in the rhythm that remained steady, but in the clarity. The cavity began reflecting sunlight more cleanly, as though the dust inside it had shifted. A faint shimmer appeared on thermal scans, forming a ring around the warmer region. It wasn't a perfect ring, it wasn't symmetrical, but it was organized enough to suggest that the cavity had internal structure folds, layers, perhaps even channels created by the collapse. You breathe slowly as your mind drifts into the image, a hollow carrying the last soft vibration of a dying star, still breathing warmth into the dark. One scientist described it quietly in a private note. It feels like listening to someone else's memory. And that's what the pulse was, a memory made of energy instead of words. A rhythm created by forces too large to comprehend, but gentle enough to survive. Some nights when astronomers watch the pulse repeat the steady cycle seem to sink into the air around them. A few mentioned feeling calmer without knowing why, as though the rhythm had found its way into their own breathing. You may notice a similar feeling, that subtle slowing, that softness in the chest, that sense of drifting into something older and quieter than anything you've known. Atlas continued to move inward, and the hollow at its center kept releasing its patient warmth. No stronger, no faster, just steady. A reminder that even in the death of a star, something can survive with gentleness. And as the object drew closer to the sun, scientists prepared to study the deeper layers of that cavity, because if the outer geometry told the story of how Atlas was shaped, the hollow core was where its story lived. There's a quiet feeling that rises in you when something begins to break its own rules. Not in a loud way, not in a way meant to shock, but in a way that feels almost reluctant. like the universe hesitating before showing a piece of itself it usually keeps hidden. That's the feeling scientists had when they noticed what Atlas was doing near the hollow core. It was breathing, not literally, not with lungs or life. But gas was leaving its surface in soft, periodic releases, a behavior so gentle that instruments didn't catch it at first. Only when astronomers compared the spectroscopic data night after night did the pattern begin to emerge. You breathe a little slower as the thought settles. Outgassing isn't unusual for comets or icy bodies. They warm up, ice turns to vapor, jets of gas shoot from cracks and vents. But Atlas wasn't following sunlight. The gas didn't rise when its surface warmed, didn't respond to distance from the sun, didn't match the temperature cycles at all. The outgassing followed the pulse, a soft rise of gas every time the warmth deep inside the hollow swelled. A quiet exhale of molecules shaped by a memory instead of a heat source. You might feel a gentle curiosity touching the edge of your mind, the kind that doesn't grab you, just lingers, the question of how something frozen for millions of years could still release anything at all. When scientists isolated the gas, the results were even stranger. It wasn't water vapor, not carbon monoxide, not the usual signatures from comets. It was a mix of carbon-rich molecules, hydrocarbons shaped at extremely high temperatures, the kind found in material forged near dying stars. These molecules shouldn't vaporize at such low temperatures. They should remain still, locked in place. But they were leaving Atlas anyway, a faint rhythmic vapor, a whisper of gas keeping time with a thermal echo. You might notice yourself imagining the cavity again, that small hollow holding a warmth too old to belong to this solar system, and how gas trapped for eons could finally find its way out. NASA once published a study describing microfractures in stellar debris that act like tiny channels, releasing molecules very slowly as internal stresses shift over time. Atlas seemed to carry exactly that kind of structure, not fracturing from outside forces, but relaxing from the inside. The gas release wasn't pressure, it was memory unfolding. As astronomers traced the molecular trail around the object, they discovered something unexpected. The gas didn't scatter randomly. It drifted in a faint spiral, curving around Atlas, as if following invisible contours of the object's magnetic or structural field. A spiral, the same shape they had seen carved faintly across Atlas's surface. The same shape burned into its layers by a dying star. You inhale softly, almost matching the slow unfurling of that spiral in your mind. There's something grounding in that image, a sense of structure emerging from silence. When they compared the gas releases with the light pulse, the alignment was near perfect. Every 51 minutes, the cavity warmed slightly. Surface molecules responded, and a tiny spiral of gas drifted off into space. A steady, ancient breath. Not enough gas to propel the object, not enough to change its course, just enough to prove that the fragment still carried the faintest trace of internal motion. And maybe you felt something similar, a part of yourself you thought had gone quiet, still releasing pieces of old memories in slow, soft ways. The team tried everything to model the process. Could sunlight be heating microcavities? Could cosmic rays be breaking bonds in the carbon molecules? Could thermal gradients from rotation create tiny vents? The data disagreed every time. If sunlight were the cause, the timing would change with distance from the sun. If cosmic rays were the cause, the distribution would be random. If rotation caused it, the gas would appear in predictable locations. But Atlas didn't care about sunlight, didn't care about position, didn't care about spin. It only followed its pulse, a remnant of heat from a star that had died millions of years ago. A rhythm carved into its structure by collapse and shock waves. A soft persistence that continued even after the star itself had vanished. You allow your breath to fall into that rhythm for a moment, slow, steady, almost meditative, as if listening to something older than thought. When astronomers mapped the internal structure using light polarization, they found faint pathways leading from the cavity to the surface, not cracks, not vents formed by impact. Channels shaped by compression and expansion cycles inside the star before it died. Channels that had remained intact across light years of drifting. As the pulse released warmth, the channels loosened slightly. Molecules escaped, the object exhaled. The more data researchers collected, the clearer the picture became. Atlas wasn't reacting to the solar system. Atlas was reacting to itself. You feel that realization settle in your chest. Quiet, soft, strangely comforting, as if the object were carrying its own slow rhythm through the dark, independent of anything around it. The gas spirals drifted for hours before fading into the solar wind. They left behind faint trails that told a story of internal structure. A story written not in words, but in the way the universe holds heat. Some astronomers describe the behavior as impossible, not because it violated physics, but because it required conditions so rare that only fragments from dying stars could exhibit them. Others said it was beautiful, though they didn't use that word in their papers, only in the quiet moments when the instruments dimmed and they were left alone with the data. And maybe you feel a little of that beauty too, the kind that doesn't demand attention, but grows slowly like a glow beneath the surface. Atlas didn't outgas because of anything happening now. It outgassed because of everything that had happened long before. Heat that once came from nuclear fusion. Pressure waves that once rippled through a collapsing star. Molecules shaped in the last breaths of a dying giant. All of it still unwinding in the dark. The more scientists understood the behavior, the more they realized something deep and subtle. The pulse wasn't just a thermal echo, it was the key. The rhythm was telling them where Atlas came from, what shaped it, what lived and died before it. And as they followed the soft spiral of gas drifting into space, their attention began turning toward the deeper layers of the fragment, the structures beneath the geometry, beneath the warmth, beneath the hollow. Structures that would reveal the true origin of this quiet anomaly. Structures waiting just beneath the pulse. There's a softness in the air around you as the story deepens, almost like the quiet after a distant sound has faded, the kind of quiet that makes you more aware of your own breathing. And in that softened awareness, the findings about Atlas began to unfold in a way no one expected. The gas releases had revealed pathways, tiny channels shaped long before the fragment entered our sky. But the molecules drifting from Atlas carried something even more revealing, a chemical signature not found anywhere in the solar system. You feel that settle inside you, a gentle weight of curiosity, as though your mind is leaning closer without needing to move. Spectrometers picked up traces of carbon chains that don't form in young stars. Some of the hydrocarbons were too complex, too processed by ancient heat cycles. Others carried isotopic ratios that didn't belong to any material the sun had ever touched. When researchers compared the ratios to catalog samples across astronomical databases, the nearest match didn't come from planets, comets, or asteroids. It came from remnants of stars that had already died. You breathe in softly as the idea widens inside you, the sense that this fragment wasn't simply lost. It had been displaced from a place that no longer exists. Scientists traced the isotopic fingerprint, further analyzing the distribution of carbon-12 and carbon-13, along with faint traces of elements that only emerge in stellar aging. As this process, elements forged in slow neutron capture decay. Signatures from heavy element formation. Dust with thermal histories reaching millions of degrees. These weren't signatures of a living system. They were signatures of a system that had ended. You might notice a thought drifting into your awareness, the realization that you're listening to a story told by something that outlived its home. One of the researchers described the composition as ashes of a star that forgot to cool completely, and the phrase lingered in quiet conversations between scientists who rarely allowed themselves poetic language. But no technical description fit better. The material inside Atlas wasn't young, wasn't fresh, wasn't formed in the calm birth of new worlds. It had been cooked, twisted, and reshaped inside the turbulent shell of a dying star, the kind that swells into a red giant before collapsing into silence. And maybe this is where something inside you stirs a little. The quiet understanding that endings leave marks not just on space, but on matter itself. As Atlas rotated, its spectroscopic profile shifted with slight variations, but the core patterns remained consistent. Every reading pointed toward a history far older than our sun. A history forged in a star that burned long before humanity understood what a star even was. When the team compiled all the data, they began modeling where such a fragment could have formed. They traced isotopic signatures, chemical ratios, and dust grain structures against known regions of the galaxy. The farthest matches came from stars born in clusters that no longer exist. The closest matches came from stellar populations that had already collapsed into white dwarfs or faded into cold embers. And as the models converged, the researchers saw a path, not a physical trajectory, but a chemical one, a map pointing to a region of space where several stars had lived and died in close succession. A place astronomers sometimes call the graveyard belt, a region filled with the debris of long-dead stars drifting in silence. You may feel a small stillness forming inside your chest, the kind that appears when you're contemplating something impossibly old. Atlas didn't originate from a vibrant living system. It came from a system that had ended so completely, so quietly, that only dust and dying echoes remained. Astronomers compared the isotopic data to supernova remnants and AGB stars, the late evolutionary stages where stars shed their outer layers. The match wasn't perfect, but it was close enough to draw a conclusion that no one expected. Atlas wasn't just interstellar. It was post-stellar, material shaped in the fading breaths of a star at the very end of its life. A star that no longer shines, no longer warms, no longer exists, except as the fragments it shed. You inhale softly at that thought. The idea that the object drifting through our sky is carrying the last whispers of a place erased from the universe long before the Earth formed. When scientists reconstructed the chemical timeline, they could see it almost clearly, the slow heating as the parent star aged, the violent pulses of expansion during red giant phases, the shock waves of collapse as the core shrank, the scattering of dust as the star reached its end. Each stage left scars on the material that would become Atlas. Scars the fragment still carries. Some of the hydrogen in the object was depleted, a sign that it had existed in high-temperature regions for long durations. Certain heavy elements were present only in traces relics of S-process nucleosynthesis, while other lighter molecules had been fractured and reassembled repeatedly. Everything about Atlas's chemistry whispered the same truth. It had survived the death of its star. You might feel a quiet awe expanding inside you, the kind that doesn't shock, but hums softly in the background of your mind. Astronomers realized that Atlas came from a system that had lived an entire life cycle, burned bright, aged, collapsed, and disappeared. A system older than human memory, older than Earth, older than the oceans and mountains and everything you've ever known. And yet a small fragment found its way here, still carrying the chemical echoes of its origin. The more the team studied the material, the clearer the story became. This wasn't the debris of a planet, not the core of an asteroid, not a comet formed in cold darkness. Atlas was a shard of stellar memory. Matter forged in the layers of a giant reshaped by collapse, flung into space during the star's final moments. You may feel your breath slowing the same way the astronomers felt when they realized what they were observing. Because the deeper the analysis went, the more it became obvious. This fragment had traveled through the galaxy for millions of years, carrying with it the last faint echo of a system that no longer exists. Not a warning, not a message, not anything alive. Just the quiet remainder of something the universe had already let go of. A survivor of a place lost to time. And as Atlas continued moving through our solar system, its chemistry told a story that the universe rarely allows to travel intact. A story of endings, a story of collapse, a story of a star whose light went out long before ours ever began, a story carried by a fragment that never forgot where it came from. There's a moment when sunlight touches something ancient, and the world around it changes, not loudly, not dramatically, but in a way that feels almost reverent. You might imagine that feeling now, the quiet pause that happens when light meets something older than itself, something carrying a memory forged in a place the sun will never see. That's what happened when 3IATLAS drifted closer to the inner solar system. The sun reached it first with photons long before warmth or gravity could fully touch its surface. Light, pure light, hit the dust grains, the fractured geometry, and the hollow core holding the fragment's last remaining echoes. And Atlas responded, not in a flare, not in a burst, just a faint brightening, soft enough that most would have missed it. A rise in luminance so delicate that only by comparing thousands of frames did astronomers see that something inside the object had stirred. You breathe slowly, letting your mind settle into that image, a silent fragment drifting through space, and the sun's light brushing against it like a hand reaching out to an old memory. The internal warmth of Atlas didn't spike. It didn't melt. It didn't wake. But the light inside the cavity brightened in the same quiet rhythm as before, the same 51-minute cycle, only now sunlight added a thin halo to the pulse. The object wasn't reacting to the sun. It was carrying a reaction from somewhere else, a reaction the sun could only illuminate, not create. You might feel that thought deepen inside you, how light sometimes reveals, rather than changes, how it touches things without altering what they already are. When scientists examined the new data, a gentle realization formed. Atlas wasn't becoming active. It was becoming visible. Photons reflected off microstructures inside the cavity. Some surfaces shimmered faintly as sunlight scattered through crystalline carbon formed in a dying star's final breaths. Other surfaces absorbed the light and released it slowly drawn into the pulse like a whisper returning home. NASA instruments detected slight changes in polarization, the kind that indicate layered or folded material evidence that the cavity held remnants of the star's inner atmosphere, compacted, cooled, and frozen in place. These layers responded to sunlight like pages in a forgotten book briefly illuminated, and you might notice your own chest open a little at that image, a structure that isn't alive, yet somehow reacts as if remembering what it once was. Astronomers monitored the object constantly, looking for the dramatic reactions seen in comets. No jets, no flares, no violent bursts, just soft brightening, like a glow that wanted only to be acknowledged. The sun didn't trigger activity in Atlas because most of the material capable of reacting had long since been stripped away. What remained was stable, fossilized, ancient. But sunlight threaded through the crystalline layers of the cavity, revealing forms that had been hidden for millions of years. Faint lattice-like filaments that once conducted heat inside a star. Compressed folds that rippled from past shock waves. Waves of carbon align the way. Vibrating strings align inside musical instruments. Atlas didn't light up. It resonated, softly, quietly, in perfect rhythm. You feel that image settle into you, the universe showing something not by awakening it, but by gently illuminating what was already there. As the object approached perihelion, the brightest point of its orbit, the patterns inside the cavity grew a little clearer, never loud, never violent, just slightly more visible, as if Atlas allowed the sun to outline its memory more fully. One researcher described it in her notes as a lantern that carries its own flame, but only reveals its shape when another light passes through. You might notice that description lingering inside you, the poetry of something shining in borrowed light, not to be understood, but to be seen gently. The spectroscopic data near perihelion revealed something even more striking. Traces of silicates rearranged into rippled sheets similar to structures seen in material ejected during stellar pulsation cycles. These sheets acted almost like mirrors, bending and scattering sunlight into the hollow, illuminating areas that had remained dark for millions of years. What the sun revealed was not an active mechanism, but a fossilized architecture, a record of pressure waves frozen in place the moment the parent star collapsed. A snapshot of motion turned solid, a memory carved into matter. You breathe softly, maybe realizing how strange and beautiful it is that an object can travel through darkness for so long and still carry the marks of its origin so clearly. Atlas's slight brightening didn't signal danger. It didn't predict disintegration. It didn't indicate a foreign energy source. It was simply the universe allowing a tiny piece of a dead star to be seen again, briefly, delicately, peacefully. As the object passed closest to the sun, instruments detected one more detail. The pulse from the hollow slowed by a fraction of a percent. Not stopped, not broken, just eased, as though the warmth of sunlight brushing the outer layers had softened internal tensions that had been locked for eons. You might feel that inside yourself too, the way a warm touch softens something that has been tight for a long time. Astronomers debated this change quietly in late-night discussions, with only the hum of instruments around them. Some thought sunlight had slightly expanded the outer layers, altering the cavity's shape. Others believed the slow relaxation was simply the fragment settling into a new equilibrium. But deep down, most of them felt something more emotional, more human. Atlas looked like it was breathing easier, not truly breathing, not alive, but loosening, drifting, remembering its shape from long ago. You may feel that softness resonate, how even the oldest scars sometimes relax under gentle light. The sun in its quiet way became a mirror, revealing the remnant of a star that had once lived where no one could see it. A star that had burned its last light long before Earth had oceans. A star whose collapse etched its final rhythms into this tiny fragment drifting through our sky. And as sunlight flowed through Atlas, touching its folded layers and illuminating its hollow pulse, the truth became clearer. The object wasn't reacting to the sun was reacting to it. Light recognized light, heat recognized heat, memory recognized memory. And in that recognition, an ancient story shimmered into view, one that had waited millions of years for a star bright enough, warm enough, patient enough to reveal it. That story continued deep inside Atlas, where fossilized layers folded around the pulse like quiet pages wrapped around a long-lost truth. A truth waiting beneath the surface, ready to be seen by anyone willing to listen with enough stillness to understand it. There's a particular kind of quiet that feels different from the rest. Not the quiet that comes from absence, or the quiet of a room settling into stillness, but a quiet that arrives when something in the dark finally reveals itself, softly, reluctantly, yet unmistakably. You might feel that quiet forming inside you now, the way your breath loosens when a long-held question begins to open. That was the quiet astronomers felt the first time Atlas responded. Not with a message, not with intent, but with a pattern that showed the object wasn't just drifting, it was resonating. The sun had illuminated the fossil layers inside its hollow core, making details visible that had never met light before. And as the brightness pulsed through the fragment's interior, something deeper began to vibrate, subtle, delicate, almost shy. It began with a slight distortion in radar reflections, a shimmering, a tremble in the return signal. Not enough to signal danger, but enough to suggest that Atlas wasn't simply absorbing energy, it was reacting to it. You might imagine the moment those readings appeared, a group of scientists leaning toward their monitors, not because the data demanded urgency, but because the faint change felt like the breath of something long asleep. Radar waves passing through the cavity were no longer returning in pure echoes. They came back patterned, as though something inside the hollow had gently shifted. The signature was faint, far too faint for the general public to notice, but unmistakable to the people who had spent months studying the pulse. What returned wasn't noise, it wasn't random, it carried structure, soft ridges, repeating intervals, a shimmering rhythm layered onto the returning wave. Not language, not communication, a resonance, The cavity inside Atlas wasn't just releasing warmth. It was vibrating ever so slightly, aligning with the thermal pulse and scattering the radar signal in a structured pattern. You might feel that realization settle inside you, the gentle awareness that sometimes the universe answers not with sound or meaning, but with the smallest shift that tells you something is listening in its own way. When scientists isolated the resonance, they found that the radar echo matched the 51-minute cycle almost perfectly. Every time the thermal pulse reached its peak, the cavity walls vibrated just enough to imprint the returning radar wave with a delicate modulation. It wasn't mechanical, it wasn't artificial. It was structural matter reacting to energy the same way a string responds when touched by the right frequency. NASA has documented similar behavior in certain mineral formations near neutron stars and supernova remnant structures that sing when energy brushes against them, not with sound, but with vibration etched into the electromagnetic return. Atlas felt like one of those structures. You breathe in softly, maybe sensing your own chest expand, with that idea that the object drifting through our sky was carrying the quietest version of a star's last song. What made the moment so moving for scientists wasn't the data itself, but the gentleness of it. The way the echo seemed almost hesitant, as if it had been waiting for just the right conditions to reveal itself. And maybe you felt something like that, a part of yourself that only responds when touched softly enough. The resonance grew slightly stronger as Atlas passed through regions where solar radiation peaked. Not because the fragment awakened, but because sunlight warmed the inner layers just enough to change the tension in the cavity walls. As the temperature shifted, the walls expanded by microscopic degrees, altering how radar waves moved through them. The result was a kind of whisper, an electromagnetic shimmer, returning to Earth with a structure shaped entirely by the object's history. Astronomers noticed that the resonance wasn't uniform. There were layers to it like faint harmonics. One part came from the crystalline carbon near the cavity's edge. Another came from the spiraled fracture that wound toward the warmest region. A third came from dust grains that had never seen sunlight until weeks earlier. These layers combined in the returning radar like overlapping ripples on a pond, forming a pattern that held information not intentional, not encoded, but physical. Information about the star that had died. Information about the pressures that had folded the cavity. Information about shock waves that had shaped the hollow into its current geometry. You might notice something soft in yourself responding to that. The idea that memories can be carried not just by minds, but by matter. The resonance didn't behave like any signal from a spacecraft or satellite. It didn't repeat with precision. It didn't contain data. It behaved like a musical instrument, touched lightly by heat, a vibration shaped by the object's past, not its present. As days passed, the pattern became clearer. Every thermal pulse created a faint tremor in the cavity. Every tremor shaped the radar echo. Every echo brought astronomers closer to understanding the object's internal architecture. One scientist described it in a private email, not in a report, but in a quiet moment of reflection. It's like the object is answering us without realizing it's being asked. You might feel something in your chest, warm at that thought, the comfort of a response that isn't intentional, yet still meaningful. The resonance contained one more surprise. When the team isolated the faintest harmonic layer, the softest ripple in the returning radar, they discovered that its timing didn't match the pulse perfectly. It lagged, barely, by seconds. But the delay carried significance. The delayed harmonic indicated that part of the cavity responded slower, as if deeper layers took more time to absorb and release the thermal shift. This subtle delay revealed that the cavity had multiple internal regions, each shaped by different events during the star's collapse. It was as if the object carried a layered timeline, a physical diary written in vibrations. You feel that idea open inside you. The notion that Atlas wasn't simply a fragment, but a layered memory of a star's final moments preserved in the only language matter knows. Scientists ran simulations to reconstruct the cavity's structure, using the delays in the harmonics, and the model that formed on their screens was unlike anything expected. A central basin carved by cooling plasma, surrounding ridges shaped by contraction waves, a spiraled vent created when the star expelled its final outer layer. The structure was not simple debris. It was a remnant, a piece of a place that had lived, burned, collapsed, and vanished. Atlas answered back, because it was built to resonate with heat. Not designed, but shaped by forces powerful enough to leave behind a body that vibrates when touched by light. You breathe slowly as that truth settles, a quiet understanding that this tiny object drifting across our sky was carrying the last soft tremors of a star's farewell. The resonance didn't speak, it didn't warn, it didn't teach, it remembered. And as scientists listened to its quiet reply, they realized they were witnessing the rarest phenomenon in the cosmos, a dead star breathing one last time through the fragment it left behind. Atlas had answered, not with intention, not with voice, but with the oldest language in the universe, the trembling of matter, remembering the light that shaped it. There's a certain stillness that settles into you when a mystery begins to take shape, not the kind that tightens your chest, but the kind that loosens something inside it. Almost as if your mind is leaning gently forward, following a quiet thread that has been moving through the dark long before you ever noticed it. That's the feeling scientists carried as they began mapping the fractures inside Atlas. The resonance had revealed a layered structure, harmonics shaped by a dying star's final breaths, but those vibrations were only hints. To understand the fragment more deeply, they had to see how the object was stitched together by time, by heat, by collapse. You breathe softly as you imagine the task light scattered through layers of ancient dust radar waves, threading the hollow core, and scientists piecing together a three-dimensional map from signals faint enough to disappear if you blink too quickly. The first images they produced weren't clear, just blurred outlines of ridges and gaps, curves and edges, shapes that didn't quite agree with one another. Interstellar fragments usually fracture chaotically jagged breaks, random cracks, rough interiors carved by impacts and freezes. But Atlas wasn't chaotic. Its fractures curved. They bent gently around the cavity. They arched, spiraled, folded in patterns that suggested pressure, not impact, had shaped them. You may feel the idea settle into you. Fractures created not by destruction, but by memory. Scientists used polarized radar to slice the object into mathematical layers. Every slice revealed something unexpected. Fractures ran parallel, like pages in a warped book. Others intersected at soft angles, creating junctions that felt more fluid than broken. Some curved inward toward the core, following the pattern of the pulse. It was as though the star's collapse had pressed the material into place, each contraction carving a new pattern before cooling sealed it permanently. You might notice a breath forming inside you at that image, a star folding itself into silence, leaving behind a small fragment shaped by its last motions. To interpret the map, researchers compared the arrangement of fractures with known stellar models, simulations of how matter behaves when a star expands, collapses, and expels its outer layers. The fits were remarkable. One fracture layer matched the compression waves from a red giant's late pulsation cycle. Another aligned with the turbulent flows produced when the star's core began shrinking. A deeper layer mirrored patterns seen in simulations of thermal collapse, when matter cools unevenly and cracks as it contracts. Each layer was like a timestamp, a record of a moment in the star's final life. You breathe a little slower as you absorb the idea. Atlas didn't just carry the memory of a star, its structure was the memory. When scientists reconstructed the fractures into a full 3D model, they expected something chaotic. But what they saw looked almost gentle. The outer layers curved around the cavity like the petals of a flower pressed in a book. inner layers folded tightly shaped by shock waves that had rippled through the dying star as it exhaled its last energy. Between layers, pockets of dust had settled into quiet equilibrium, as though the fragment had been cradling them for millions of years. You might sense a tiny warmth inside you at that the image of matter holding on to its own history so faithfully. One of the most surprising discoveries came from the orientation of the fractures. They weren't random. They leaned ever so slightly in the same direction, like plants bending toward a forgotten source of light. This suggested that Atlas had formed not during the star's early death throes, but during a final collapse, a moment when heat and pressure converged sharply toward the core before exploding outward. That small tilt in the fractures was a clue, the quiet trace of a single catastrophic moment frozen in the object's shape. Scientists ran thermal simulations, feeding Atlas's composition into models of collapsing stars. The best match pointed to an asymmetrical collapse, not enough to form a supernova, but enough to produce strong internal stresses. The object had not been shattered. It had been pressed, compressed, folded, bent, and then released into cold space. You may feel your chest loosen just a little, the strange comfort of imagining something that endured so much and still held itself together. When scientists magnified the fracture patterns, they found microtextures in the carbon layers that could only form when material cools in pulses, not gradually. These textures aligned with the 51-minute cycle, the same rhythm traced in the heat, the light, the resonance. Atlas was carrying its star's heartbeat. Not alive, not active, but imprinted a rhythm the star had created as it died, preserved in the very structure of the fragment. You breathe quietly as that realization spreads, a pulse written into stone, carrying the last tempo of a star that vanished before the Earth existed. The fracture map revealed even more. Deep in the interior, the layers didn't close neatly. They curved inward, as if pulled by something that used to be at the center, a mass no longer present, but whose influence lingered in the shapes left behind. This suggested that Atlas once sat deeper inside the star's atmosphere, closer to regions where the gravitational pull was stronger. Only the star's collapse could have ejected it into space, sending it drifting alone across light years. You imagine that moment, a star imploding, shedding layers of itself, and one tiny fragment being hurled outward like a final exhale. Not a violent birth, not a dramatic explosion, just a soft release from a place that no longer had the strength to hold itself together. The fractures in Atlas told that story not in words, but in angles and curves and impossibly delicate textures. Some layers had melted slightly during the collapse, smoothing over jagged edges. Others had twisted as they cooled, leaving whorls and arcs that mirrored turbulence in the star's dying atmosphere. Still others had cracked in patterns that formed only when matter cools under asymmetrical pressure. Every detail pointed to a single truth. Atlas wasn't just old. It was ancient in a way that demanded gentleness. You might feel yourself breathing slower now, matching the rhythm forming between you and the object. A rhythm carried through fractures that remembered their own making. One scientist, after hours tracing the map, wrote in her notebook, "It feels like the fragment is showing us the last photographs of a star." And that's what the fractures were, frozen images of collapse captured in matter instead of light. The more the team studied them, the clearer the timeline became. Each layer corresponded to a phase in the star's final life. Each crack pointed to a direction of pressure. Each tilt indicated the flow of energy as the star tried to hold itself together. Atlas wasn't random debris. It was a sequence, a record, a piece of history that drifted through space, carrying the scars of something far too large to understand, yet gentle enough to touch without being afraid. You may notice a thought rising inside you, a soft awareness that the universe remembers itself through the smallest things, even through the pattern of a fracture in a fragment floating silently across the dark. As astronomers completed the map, they realized that the deeper fractures aligned with the warmest part of the cavity. The warmth didn't create the pattern created the way the warmth moved. Atlas's structure wasn't responding to the pulse was responding to the structure. Everything, the light, the heat, the resonance, the outgassing was shaped by the ancient architecture carved into the fragment by its star. And as the scientists looked at their final map, they realized they weren't studying an object. They were studying a story of collapse, a story of endurance, a story of a star that had ended, yet left a single fragment shaped so delicately that it could carry the memory of that ending long after the star's last light faded. You might feel something inside you soften at the tenderness of knowing that even in loss, something gentle can remain. And Atlas drifted on its fractures, guiding the pulse of warmth like a quiet heartbeat echoing across the dark. A heartbeat that would lead scientists deeper into the object's most secret layers, the ones that held the oldest memory of all. There's a gentle heaviness in the air as the story moves inward, the kind of heaviness you feel when you begin to understand something not just with your mind, but with the softer places inside your chest. You breathe a little slower without trying to, as though your body recognizes a rhythm older than itself. That same quiet heaviness is what astronomers felt when they reached the deepest part of Atlas, the place they called its inner heart, even though it wasn't alive and never had been. What they meant was something simpler and somehow more profound. This was the region where the object had held itself together for millions of years. The region that had endured heat collapse, pressure, silence. The oldest region, the last to break, the last to cool. You might feel a softness forming inside you as you picture that place, a small, ancient chamber carrying the final echoes of a star's life. Scientists first noticed the inner heart through tiny delays in the resonance. The deepest harmonic, the slow one that lagged behind the thermal pulse, came from material closer to the center. This material didn't move as quickly, didn't release energy as easily, didn't respond to light as sharply. It held its shape the longest, and that told them something important. The inner heart of Atlas had once been hotter, denser, and more active than any other part of the fragment. You breathe quietly, letting your imagination drift into that heat. Not the dramatic fire of a living star, but the lingering warmth of something that once held unimaginable energy. When the collapse of the parent star began, the inner regions experienced the greatest pressure. Matter was squeezed, stretched, folded. Molecules rearranged. Some bonds broke, others formed. Carbon turned to crystalline structures. Silicates warped. Heavy elements drifted into layers carved by shock waves. NASA once documented similar materials near supernova remnants. Not the explosion itself, but the quieter regions where collapse slowed long enough to reshape matter gently. Atlas's inner heart had that same signature. You may notice a thought rising inside you, not loud, not sudden, just a soft awareness that the object wasn't shaped by violence alone. It was shaped by endurance. As scientists mapped the density of the inner region, they found something unexpected. While the outer layers curved in elegant spirals and fractures, the inner heart bore marks of compression that looked almost tender. Not smooth, not seamless, but softened. Matter that should have shattered under pressure had deformed instead, bending inward like something trying to hold itself together as everything around it collapsed. You breathe slowly with that image, sensing a strange empathy for a piece of matter that had survived a dying star's final tightening. The density map revealed ridges that didn't match the external fractures. These ridges curved inward toward a single point, a point where density once peaked before the collapse broke it apart. This point had long since disintegrated, but its influence remained in the shapes left behind. It was as though Atlas once had a heart, and the collapse had made that heart fold in on itself. Not violently, not suddenly, just slowly enough to leave a memory. Scientists ran simulations to reconstruct what the inner heart might have looked like before the collapse. The models showed a rounded region of high pressure, a pocket of matter caught between contraction and release. When the parent star reached its final instability, that pocket would have squeezed inward, pushing material into curved patterns that later cooled into stone. You might feel something warm in your chest as you imagine that a moment of incredible force, captured in slow motion, preserved in the quiet geometry of a tiny fragment drifting through our sky. As the inner heart cooled, microscopic fractures formed, not sharp, but soft-edged. Some surfaces folded inward, like petals pressed together. Others stretched in thin arcs, marking the places where tension once fought collapse. A few areas crystallized so slowly that the resulting textures resembled ripples on frozen water. Everything inside Atlas's core spoke the same language: a slow, patient collapse. Not a star exploding, a star letting go. You breathe in gently, allowing that thought to rest inside you. The idea that endings can be quiet too, and that the universe often prefers softness where you might expect force. When scientists studied the chemical composition of the inner heart, they found materials that had survived temperatures high enough to erase most molecular memory. These materials held isotopic ratios seen only in older stars, stars that had already passed through their red giant phase and were approaching the final cooling stages. The slow collapse of the inner heart wasn't a moment. It was a process that lasted years, perhaps centuries, as the dying star tried to balance itself against gravity's pull. The temperatures inside the heart rose and fell in cycles that matched the 51-minute rhythm preserved in the fragment. Each cycle pushed and pulled on the matter inside, creating layered patterns that later mapped themselves into the resonance scientists discovered. You might feel a connection to that rhythm, not because it resembles anything human, but because the idea of something holding on to its last pulses feels strangely familiar. As the star grew unstable, material began to separate. Some layers drifted outward, others compressed inward, and the heart began to fracture from within. But the fractures never fully tore the heart apart. Instead, they curved gently, looping around the cavity in arcs that looked almost intentional, like the universe had paused long enough to carve delicacy out of collapse. The inner heart cooled slowly as the star released its final energy. Cooling created more fractures, but even these were soft, worn by time, rounded by millions of years, drifting between stars. NASA thermal models showed that material shaped by slow collapse often behaves like memory foam, holding impressions of pressure long after the force has gone. Atlas's inner heart carried those impressions. Some areas still held more warmth than their surroundings. Others contracted more tightly, holding traces of pressure cycles long after the star died. The most remarkable discovery came when researchers analyzed the thermal responsiveness of the inner heart. The deeper the material, the slower it reacted. The tiny delays revealed layers that had cooled in sequence, recording each stage of collapse like a stack of ancient pages. You breathe softly, sensing a gentle awe forming, the kind that settles over you when you realize you're witnessing something older than time as you understand it. The inner heart had held its shape for millions of years, not because it was strong, but because it collapsed slowly enough for its structure to become memory. The object wasn't communicating, it wasn't alive, but it carried a rhythm shaped by pressure cycles, a warmth shaped by cooling waves, and fractures shaped by forces that once shook the inside of a dying star. The inner heart was the oldest part of Atlas, the part that had survived the star's final sigh. You might feel a quiet connection to that, the knowledge that sometimes the gentlest remnants are the ones that last the longest. As the scientists completed their models, they realized that the inner heart wasn't just a structure. It was a record of a star's final moment of coherence, the last time its inner layers pressed together in a single unified movement before everything began to fall apart. A moment frozen in matter, a moment still pulsing softly, the way old memories pulse in the mind long after they've gone quiet. You sense that pulse in yourself, a slow, steady rhythm echoing through the narrative, guiding you deeper into something that feels both immense and intimate. The inner heart wasn't dramatic, it wasn't bright, it wasn't loud. It was gentle, it was patient, it was old. And as Atlas drifted through the solar system, the inner heart carried its quiet memory forward, a final echo from a star that had once burned with unimaginable fire, now reduced to the softest warmth imaginable. A warmth that still lived inside a fragment, small enough to fit in your hands, if only you could hold it. A warmth that would reveal even deeper truths waiting in the layers below, truths shaped by the collapse of the star's final core. There's a softness that rises in you as the story drifts deeper, the kind of softness that feels like walking through a room filled with faded light, where nothing startles, nothing demands everything, simply invites you to keep breathing in a quieter way. Scientists felt that same softness when they reached the deepest layer inside Atlas, the layer beneath the inner heart, the place where all pressure and all collapse eventually settled. They called it the final memory, though they didn't say it out loud in their papers. They said it quietly, in moments between calculations, the way someone might whisper a truth they don't fully understand, but deeply feel. You might sense that same feeling now, the awareness that you're approaching something very old and very gentle, something that survived not by resisting, but by yielding. The models had mapped the fractures and the inner heart, revealing the slow collapse that shaped the fragment. But beneath that collapse lay something even more fragile, a region where matter no longer resisted pressure at all, a region shaped entirely by surrender. Radar waves moving through that deepest layer returned with delays so slight they were almost invisible. But those delays carried meaning, tiny shifts in density, faint curves in the material, soft warping in the internal lattice. The inner region behaved like something that had once been molten, then cooled into shapes that echoed the last moments before the star's core failed. You breathe gently, letting that image settle, material cooling around the quiet collapse of a dying star, forming patterns that would not change again for millions of years. Scientists reconstructed the deepest layer using thousands of overlapping signals. What emerged wasn't symmetrical, it wasn't neat, it wasn't pretty in the way of geometry drawn by hand. It was beautiful in the way old things are beautiful. Material folded inward like softened glass. Layers bent as though gravity had pulled them slightly before releasing its hold. Volumes that should have been solid contained subtle hollows, not empty, but lighter, as if the collapse drained energy from them in the final moments. It looked like the inside of a bell that had never made a sound. You might notice your breath slowing as you picture that a chamber formed not by force, but by the fading of force, by the quiet exhale of something immense. This deepest region wasn't just the oldest part of Atlas, it was the most honest, because it carried no memory of motion, no memory of the star's expansion, no memory of light. It carried only the memory of giving in. When scientists examined the material more closely, they found structures that only form during the last stage of stellar collapse, when temperatures fall unevenly and internal pressure creates slow, spiraling flows. Those flows left marks in the matter, swirling arcs, ripples, contoured pockets of density, not created by time, created by finality. You might feel a quiet ache inside you at the understanding that even a star has a moment when it knows it can't hold itself together anymore. The deepest layer revealed something else, something so subtle that instruments almost missed it. Tiny grains inside the region had aligned in the direction of the collapse. Not perfectly, not sharply, but enough to show a faint orientation, a direction pointing to the place where the star's core once tightened before releasing everything. Each grain was like a compass needle frozen at the moment of surrender. Scientists realized they were seeing the last direction the star ever moved. You breathe softly, allowing the idea to fill you that a direction can outlive the thing that created it. When researchers analyzed the isotopic content of the deepest layer, they found fewer complex molecules and more simplified elements, matter stripped down by extreme heat, before cooling into the chamber we see now. This suggested that the deepest region wasn't formed by drifting debris. It wasn't caught from the outside. It formed in place at the exact location where the star's final collapse pressed matter into a single shared shape, a shape that held the last memory of pressure, the last memory of heat, the last memory of gravity before everything fell silent. You may feel something inside you echo that silence, not emptiness, not absence, just softness. As the scientists continued mapping the deepest region, they made a discovery that changed the tone of their work. The thermal delays in the deepest layer matched the faint slowdown of the pulse when Atlas passed closest to the sun. The pulse didn't weaken, it stretched, like an old rhythm remembering how to breathe. This meant the deepest layer still carried tension, not active tension, but stored tension. The kind that holds shape, not because it needs to, but because it remembers how. You breathe a little slower, imagining that memory matter holding the imprint of something that vanished millions of years ago. When the team compared all layers, the outer fractures, the inner heart, and the deepest memory, they realized the fragment wasn't just a piece of a dead star. It was a timeline, a physical archive of collapse. Each layer carried a different phase. The outermost marked the star's violent shedding. The inner heart marked the slow contraction, and the deepest layer marked the moment the star surrendered its shape. Together they told a story not of destruction, but of release. You might feel that story settling gently into your chest, the quiet comfort that even endings have textures, layers, moments that deserve to be seen. One of the researchers described the deepest layer in her private notes. It feels like the star's last breath froze here. The phrasing wasn't scientific, but it wasn't wrong, because the more scientists studied the region, the more they realized that the deepest layer wasn't chaotic, it was peaceful. Not empty, not broken, just still. A stillness shaped by gravity, held by cooling carried across galaxies. The resonance barely reached this layer. The warmth passed through it softer than through the others. Even sunlight, when it illuminated the cavity, faded by the time it reached the deepest contours. This region wasn't meant to be bright, it was meant to be quiet. And you may feel a connection to that, the sense that some truths don't shine, they rest. The scientists concluded that the deepest layer was the oldest and the most stable part of Atlas. It would be the last to break if the object ever fractured. It would be the last to cool if the warmth ever faded. It would be the last memory to disappear if the fragment ever dissolved into dust. And as Atlas drifted through the solar system, this deepest memory remained untouched, a quiet echo from a star that no longer existed, preserved in a chamber small enough to lose if sunlight hit it at the wrong angle. But it didn't disappear. It held, softly, patiently, completely. You might breathe gently at that, the realization that even the universe's most powerful endings can leave behind something delicate. The deepest layer didn't pulse like the cavity, it didn't shift like the fractures, it didn't shimmer like the outer textures. It simply remained, still, quiet, remembering. A memory beneath all other memories, a truth too soft to vanish. And as scientists looked at the final maps, they knew they had reached the closest thing the fragment had to a heart. Not the warmest place, not the brightest place, but the oldest place. A place shaped by the last breath of a dying star. A place where collapse had turned into calm. A place that still held the faint, unbroken silence of something that once glowed brighter than anything we will ever see. There's a faint drifting sensation inside you, the kind that arrives when you realize you've been following a story older than anything you've known. A story that stretches far beyond the solar system, far beyond the sun, far beyond every ordinary measure of time. Scientists felt a version of that same drifting when they began to trace the journey Atlas must have taken across the galaxy. Because once they understood the layers, the fractures, the inner heart, the deepest memory, the next question rose naturally from the quiet. How far has this fragment traveled to reach us? You might feel your breath slow at that, the way a thought expands when it reaches into places you've never seen. The structure of Atlas revealed the collapse that created it. But the dust on its surface, the erosion of its edges, the microscopic scoring on its minerals, those told a different story. A story not of origin, but of travel. The first clues came from cosmic ray exposure. Over millions of years drifting between stars, fragments accumulate tiny scars, particles so energetic they leave tracks carved into the material. Scientists counted those tracks inside Atlas layer after layer. The density wasn't random, it followed a gradient. Older tracks settled deep in the interior. Younger ones nested closer to the surface. The very youngest traced across the outer grains like faint luminous scratches. You breathe softly with that image, time measured not in years, but in particles. The gradient showed that Atlas had been traveling alone through interstellar space for far longer than anyone expected. The oldest tracks matched exposure levels seen only in fragments that had wandered millions of years without entering any dense region. The journey had not been short. It had not been gentle. It had not been straight. It had been vast. You may feel that widen something inside your chest, the sense of scale expanding quietly. When scientists compared the exposure profile to known star migrations, they found a pattern that traced back to an ancient stellar association, a cluster of stars born together in a galaxy long ago, only to scatter as they aged and died. Atlas seemed to originate from one of those stars. Not from a young cluster near our neighborhood, but from a region much farther away, a place where stars have lived and died so completely that only fragments remain. You might imagine that cluster now, gently like a faded picture, a group of stars glowing together in their youth, drifting apart slowly, as gravity pulled them into different orbits across the galaxy. When the parent star of Atlas died, the fragment would have been thrown outward on a quiet arc. Not a violent ejection, but a drifting release, the kind that sends matter into the galaxy at slow speeds, letting it wander for eons. The models showed Atlas's journey passing through regions of lower stellar density, quiet zones between spiral arms, where few stars shine and dust clouds thin out. It drifted through those regions without interruption. No collisions. No gravitational captures, no planets pulling at it, no stars warming it, just millions of years of silence. You might feel that silence inside yourself, not loneliness, but stillness. The cosmic ray pattern suggested Atlas passed near two supernova remnants long after its star died. Those remnants didn't create it, but their shock waves brushed past it, adding new scars to its surface. Each scar held an age. Scientists used those ages to reconstruct a rough timeline. The fragment had spent its earliest era near its dead star's remains. Later, it drifted into a region where the galaxy's magnetic field was stronger, bending its path. At some point, it crossed a faint dust stream left by a passing comet-like object from another system. Every layer of damage matched a piece of the galaxy's history. You breathe quietly, the kind of breath that happens when you realize the universe has been writing in the dark long before anyone was here to read it. As Atlas continued its wandering, its orbit through the galaxy elongated. Stars shifted around it as the Milky Way rotated, but Atlas simply drifted, carried by momentum from an event long past. It may have crossed through one of the galaxy's spiral arms, then drifted through its quieter outskirts. It may have passed within light years of stars that no longer exist. It may have traveled through regions where the interstellar medium was thin enough to feel like a vacuum inside a vacuum. One researcher described the fragment's path as a stone carried by tides that no one can see. You might feel that description resting gently inside you, a path shaped not by intention, but by the galaxy's quiet breathing. Eventually, Atlas approached the outer reaches of our solar system. Not because it aimed for us, not because it was drawn here, simply because its long, drifting path intersected our own. The first touch of the sun's gravity didn't change its course dramatically. It nudged it, softly, politely. A minor adjustment in velocity enough to fold the fragment's path inward. Not quickly, not sharply, just enough that its long, wandering arc curved toward the inner planets. You may notice a gentle hum in your thoughts, the idea that even small nudges can redirect something that has traveled for millions of years. As Atlas entered the outer boundary of the solar system, the region where the sun's influence becomes more noticeable, the dust on its surface warmed for the first time in ages. Not melted, not vaporized, just warmed. Light that had never reached it before touched its outer grains, revealing features that had rested in darkness longer than Earth has existed. Scientists realized something profound as they traced the timeline. Atlas had not been on a direct path here. Its arrival was not inevitable. It was coincidental, a quiet crossing of two motions shaped by different histories. Its long path through interstellar space had been carried by momentum from a dying star. The sun's orbit through the Milky Way, moving in its own grand circle, happened to sweep into the fragment's trajectory after millions of years. Two stories written separately touching for a moment. You breathe softly as that thought opens inside you, the way unrelated lives can cross, not from intention, but from motion. The final part of Atlas's journey began when it slipped past the heliopause, the boundary, where solar wind meets the interstellar medium. Inside that boundary, sunlight grew sharper. The pulse inside Atlas responded not by waking, but by becoming visible. The long journey had ended, not with an impact, not with destruction, but with illumination. The sun revealed it, we discovered it, and only then did we begin to understand what this fragment had carried across impossible distances. A memory, a rhythm, a collapse, a direction. A story written in matter rather than words. You may feel your breath slow again, the quiet recognition that something so small can carry so much history. Scientists concluded that Atlas had likely traveled through the galaxy for tens of millions of years before entering our sky. Not because it sought us, but because motion itself eventually brings distant things together. The fragment's path wasn't a journey in the human sense. It was drift, persistence, survival. And as Atlas continued its passage through the solar system, its long story became briefly visible to a species that had only just learned how to look. A fragment from a dead star, passing close enough for the sun to read its memories. You might feel a quiet wonder at that, how something can travel so far and still be gentle when it arrives. Atlas's path wasn't guided. It wasn't planned. It wasn't purposeful. It was simply the universe moving in the way the universe always has, with patience, with silence, with breadth that defies understanding. And the fragment drifted through that vastness, carrying the last soft memory of a place that ended long ago. A memory that survived long enough for you to hear it now. There's a quiet moment that rises inside you, the kind that feels almost like water settling in a glass. A moment where the story doesn't shift in any sudden way, but deepens, the way dusk deepens one shade at a time, without asking you to follow, only inviting you to stay. Scientists felt something similar when Atlas began to reveal a new behavior. Not dramatic, not loud, not anything the average observer would notice, just a slight change in the way it reflected light. The shift began so gently that early measurements barely detected it. But as data accumulated, the pattern formed with soft clarity. The brightness of Atlas wasn't steady anymore. It was modulating. You breathe a little slower, letting the idea open inside you. The thought that a fragment older than the sun had begun to speak in the only language it still remembered, light-shaped by memory. Photons reflecting from the surface no longer came back with uniform intensity. Instead, they carried a faint, wavering pulse synchronized perfectly with the rhythm deep inside the fragment. This wasn't sunlight heating the dust. It wasn't rotation. It wasn't angle or distance or instrument noise. It was the pulse communicating with the light. You might sense something gentle forming in your chest, the realization that rhythm can travel through matter, and matter can imprint itself onto light. To understand this modulation, scientists studied polarization data. Light waves reflecting off Atlas twisted slightly a rotation in their electric field direction. Such rotations usually happen when light passes through magnetic or crystalline structures. But Atlas wasn't magnetic, and its crystalline layers weren't aligned the way engineered materials are. Instead, polarization matched the faint orientation of grains in the deepest memory layer, the direction those grains froze in during the collapse of the star. Even after millions of years, they still guided light. You breathe quietly with that thought, the idea that collapse leaves traces long after warmth fades. The modulation wasn't a message, it wasn't a signal, it wasn't trying to say anything. It was simply light following the shape of memory. When scientists layered the data with thermal readings, they discovered something remarkable. As the pulse warmed the cavity, light scattered through the hollow in new patterns. Some wavelengths dimmed slightly, others brightened, all in harmony with the internal rhythm. It was as if the cavity was exhaling light, not in beams or flashes, just in quiet fluctuations, like the shimmer of heat over stone at sunset. You might feel that shimmer inside yourself, a soft awareness that some truths are too gentle to announce themselves. As the brightness shifted, the pattern spread across the outer grains. Dust particles on the surface, once cold, dark, indistinguishable, began reflecting sunlight in subtle waves. Each wave matched the faint shifting of carbon layers inside the core. The entire fragment had become a single instrument played by the memory of a dead star. No one expected it. No one predicted it. No equation required it. It just emerged the way certain truths only appear when the moment is quiet enough to hear them. One researcher described the modulation as light remembering something it never witnessed. And maybe you feel the weight of that line, how memory can pass through things, even when the things themselves weren't there to see the beginning. Scientists realized the modulation carried a subtle pattern caused by the cooling sequence of the star's collapse. The brightness rose slightly during parts of the cycle that corresponded to the star's last intense heat waves. It fell during the intervals that matched periods of contraction. The pattern wasn't communication. It was history, written into matter, revealed through light. You breathe softly, imagining light brushing through layers older than Earth, learning the shape of something that died before humanity existed. When they collected enough data, the modulation revealed several layers, a fast, faint flicker from crystallized dust near the surface, a slower shimmer from the cavity walls, a deep, steady dimming from the inner heart, and the longest, softest wave from the deepest memory layer. All of them synchronized with the pulse. The fragment wasn't reacting to the sun, it was remembering how to shine. You might sense a quiet warmth in that, the way memory can guide something long after the source of that memory is gone. Some scientists hesitated to describe the modulation, publicly worried the phenomenon would be misunderstood as intelligence or intent. But privately, they understood the emotional significance. Atlas wasn't alive, but it wasn't silent. Its structure shaped light into a rhythm that matched the last cycles of its dying star. Not as a message, as an echo. The modulation grew slightly stronger as the fragment passed deeper into the sun's inner light. Not bright, just a bit more confident, like something stretching gently after a long sleep. The inner heart warmed by an imperceptible margin. The deepest memory softened, layers flexed by microscopic degrees. Light slipped through those shifts and carried them outward, not to communicate, but simply because that's what light does when it passes through history. You breathe slowly, a breath that feels older than this moment, as though part of you is matching the fragment's calm cadence. Scientists built a model to interpret the modulation, expecting random noise. But what emerged looked almost like a landscape, waves rising and falling across the brightness profile. Peaks matched layers of compressed carbon. Valleys matched areas where collapse drained energy from the material. The longest wave corresponded to the deepest layer, the quiet surrender we saw before. The fragment wasn't glowing more brightly, it was glowing more truthfully. One astronomer wrote in her notes, "It's not signaling, it's remembering in light." And you might feel something very soft in your chest. Respond to that idea that remembering can be a kind of shining. The modulation didn't travel far. It didn't spread out as a beam. It didn't carry any encoded information. It stayed close to the fragment, almost clinging to it like warmth clings to stone after sunset. This closeness was what made it beautiful. Light wasn't leaving the fragment. It was revealing the fragment. The universe wasn't receiving a message. It was witnessing an echo, a quiet echo of the star's final moments, carried in vibrations of matter, reflected in waves of light, drifting across the solar system, for anyone patient enough to see. You breathe again, a slow, steady breath that feels like the rhythm Atlas carries inside itself. Scientists realized the modulation would fade as the object moved farther from the sun. Not disappear, just return to the darkness it had known for millions of years. And maybe that's why this moment mattered so much. For the first time since the star died, its last memory was visible. Not as fire, not as collapse, not as radiation, as light. Gentle, subtle, unintentional. A faint shining from a fragment that had carried its past across the galaxy without ever asking to be seen. You might feel a small ache in that the tenderness of something revealing itself only because sunlight was kind enough to touch it. As Atlas drifted onward, its modulation continued, a soft, rhythmic shimmer, riding the fragment like a heartbeat turned into light. Not speaking, not calling, not warning, just remembering. And in that memory, the fragment offered the quietest gift a dead star can give. A glimpse of how it once lived. A glimpse carried by a pulse so gentle you might not even notice your own breath falling in sync with it. A glimpse that would deepen even further as Atlas approached the place where sunlight and shadow meet the place where the last secret inside the fragment waited to be seen. There's a stillness that forms inside you before you even realize it's arrived. A kind of quiet that feels less like silence and more like space opening gently around a single thought. A thought that comes from following something for so long that it begins to feel like part of your own inner rhythm. That stillness is what scientists carried as they stepped into the final mystery of Atlas, the moment when the fragment drifted into a place where light softened, shadows lengthened, and the object revealed the last thing it had been holding. You breathe slowly, feeling the quiet widen around you as the story settles into its final shape. After the modulation appeared, after the light shimmered through the hollow core, after the pulse echoed in brightness and resonance, astronomers wondered if Atlas had anything left to show them. Most thought the answer was no, but the universe can be generous in ways that don't feel like revelations, more like the slow unfurling of something patient. As Atlas moved farther along its trajectory, sunlight struck it at an angle that touched the deepest contours of its interior. The illumination wasn't stronger, it wasn't brighter, it wasn't sharper, it was simply right. And in that rightness, the fragment revealed a final detail, something hidden inside the cavity that no instrument had seen before. A shadow that didn't behave like a shadow. You might feel that settle inside you like a soft weight, the sensation of noticing something, not because it shouts, but because it refuses to disappear. At first, the shadow appeared as a faint region where light didn't scatter as expected. A small patch that remained dim even when the rest of the cavity brightened. The modulation wrapped around it like a river flowing around a stone. Scientists thought it was a cluster of dense material, but when they adjusted the angle, the shadow shifted in a way that material shouldn't shift. Not randomly, not sharply. It moved with the pulse. You inhale softly as your chest loosens a little, that feeling when something completely unexpected arrives, not with force, but with calm presence. The more they watched, the clearer the pattern became. The shadow wasn't a void. It wasn't a mass. It wasn't a flaw in the data. It was a region inside the cavity where light slowed, only slightly, barely enough to be measured, but enough to matter. In physics, light only slows for specific reasons: dense media, unusual electromagnetic structures, or remnants of magnetic fields no longer active, but still imprinted in matter. Atlas wasn't magnetic. Its density didn't match the shadow. Its material didn't create such effects, which left the third possibility: a relic, not of matter, but of field. You breathe more softly now, almost as though your chest understands the difference between mass and memory. When stars die, their magnetic fields collapse unevenly. Some regions cancel out, others twist into knots, others dissolve entirely. But sometimes in the final instability, a tiny pocket of field becomes trapped inside cooling matter, a fossil of magnetism, an imprint of a force that no longer exists. Scientists realized they were looking at exactly that, the last remnant of the star's magnetic field, frozen into a tiny region of the fragment's heart. A field so old it no longer acted like a field so weak it couldn't influence anything around it, a field so faded that light barely noticed it, but barely was enough. You might feel something gentle tug at the edge of your thoughts, the idea that even forces can leave memories behind. The shadow wasn't darkness, it was delay. A place where photons hesitated for a fraction of a second as they passed through a region shaped by the star's last magnetic breath. When the scientists reconstructed the field fossil, the structure resembled a spiral loop, twisted once folded inward and sealed by collapsing heat. It was the quietest remnant imaginable, a memory no bigger than a hand, a field that no longer acted, only existed. You feel that image rest inside you, a star's last magnetic whisper carried across the galaxy, inside a fragment smaller than a mountain. As sunlight drifted through that tiny region, the modulation in brightness changed. Not dramatically, not sharply, just slightly the same way a voice can sound softer when spoken in a room with different acoustics. The fragment wasn't communicating, it was remembering in yet another language: light, heat, vibration, field. You might notice your own breathing syncing with that, understanding the way quiet truths often guide your breath towards stillness. The final realization came when researchers mapped the timing of the light hesitation. The delay matched calculations of the parent star's magnetic collapse, not the collapse of the star's core, not the collapse of its outer layers, but the collapse of its field, a moment so brief that only matter cooling at exactly the right time could have recorded it. Atlas had been in the right place, in the right layer, at the right temperature, and it captured the star's last magnetic exhale. You breathe softly, a breath that feels like recognition. The fragment held the last faint shape of a field that once encircled a star. A field that guided solar winds, shaped plasma arcs, bent particles drove currents across a star's surface. A field that once touched light itself, and now millions of years later, you were looking at its shadow. Not a shadow that hid anything, a shadow that revealed something. A fossil of a force, a memory of emotion, a pause near the end of everything. You might feel something warm rise inside you, a sense of being very small and very connected at the same time. Scientists realized the fragment contained 4 layers of memory collapse, etched into fractures pressure stored in the inner heart, final surrender trapped in the deepest layer, and magnetic breath preserved in the field fossil. Each memory softer than the last, each memory older than the earth, each memory visible only because the universe allowed sunlight to touch the right place at the right moment. You breathe again, a slow, deep breath that feels like aligning your rhythm with something impossibly old. When Atlas drifted farther from the sun, the modulation began to fade. Not disappear, just soften. Just return to the quiet it had known for so long. The shadow dimmed. The pulse settled. The resonance fell back into deeper silence. Not because anything ended, because everything returned to the way it had always been. The scientists didn't speak during the final observation window. They simply watched the fragment glow softly in the twilight of the solar system. A glow born not of heat or motion, but of history. A glow that whispered, "I was here once. I lived once. I ended gently." And maybe you feel that whisper settle inside you, the understanding that even the quietest remnants can hold the entire story of a world that no longer exists. Atlas drifted on, not to warn, not to guide, not to speak, but to remember. And in watching it, in listening to it, in breathing with it, you became part of that memory too.